Let's work an example from Lesson 9, Activity 4. So Oscar Montez's savings account has a principal of $7,201. It earns 6% interest compounded quarterly. To the nearest dollar, what's the amount in the account at the end of the second quarter? Okay, so first of all, we need to use our compound interest formula. A equals P, where P is our principal, times 1 plus or minus rate divided by n. We'll get to n in a second. N reappears in this exponent and we multiply by time. Okay. So A equals P times the quantity 1 plus R over N to the NT. Well, what does all this mean? Well, we know A is the amount, right? It's the ending amount. So if I initially invest a certain amount of money, say $1,000, and I end up with $3,000, then my amount is $3,000. So P is my principal, what I start with. R is the rate, the APR. N is the number of rates per period. And T is time in years. So we have our equation in front of us. Now ask, what are they asking us to solve? They want the amount in the account at the end of the second quarter. The amount in the account after the second quarter. Okay, so we're solving for A. Let's see what we can plug in. The principal is 7,201, so I can plug that in right away. 7,201. Do I know R? Well, R is my rate, it's my APR, which is 6%. I have to express this as a decimal though, so I write 0.06. I'll divide that by N. N is the number of times a year compounding takes place, or number of periods per year. Since I compound quarterly, there are 4 periods per year, and that N in the denominator is the same N here in the exponent. And T, finally, T is the time. In this case, we will use 2 quarters. Okay, so time in years, so T equals time in years. And we're asked to find the amount after the second quarter. So if 2 quarters of 4 quarters pass, that means half of a year, right? So our time is 0.5. Notice that I'm using 0.5 and not 2. Okay, again, time has to be in years. So 2 quarters is half a year, and I had to convert to time in years. That's the main place where you might get tripped up in this problem. From here, it's just a matter of combining terms and simplifying our problem. I would recommend starting with 7,201 times, I would recommend starting in the exponent. 4 times 0.5 is 2. I'd simplify that first. Then I'd simplify the fraction. 0.06 divided by 4 is, and then I would even convert it to a decimal, so 0.15. If I type 0.06 over 4 in a calculator, I get 0.015. Bring down my 1. I'd combine that next. A equals 7,201 times 1 plus 0.015 is 1.015 squared. And from here, this is pretty easy to type into a calculator, right? So I get 7,201 times 1.030225. Notice I'm not rounding. I carry out that multiplication and I get 7,418.66. However, I'm asked to go to the nearest dollar. So I get $7,419. Okay. Again, I like color coordinating everything and setting things up one at a time and executing my calculations one at a time. I find that minimizes error. Let's do another example. So Monique deposited $12,500 in a savings account, paying 6.5% annually, compounded monthly. How much compound interest will she have earned in 3 years? Okay, let's set it up. Now, again, I'm going to take a little bit more time to write out my equation because I'm going to color code it. So I'll have, let's see, a P, I'll have 1 plus something. So I'll have my principal, I'll have my rate, I'll have my number of periods per year, and I'll have my time. So what are they asking us for this time? How much compound interest will she have earned after 3 years? Okay, so this is going to be a little different because compound interest is part of a different formula. So to find my compound interest, I'm actually going to have to take this A and subtract it from P. So the A and the P in my compound interest formula are the same A and P over here. Okay. To find the amount of interest, I find how much I started with in the account, how much I ended with the account, and I take the difference to figure out how much money the account gained. So to get to compound interest, I first have to solve for A. So let's start with that. So A equals P, my principal, which is $12,500, times 1 plus my rate. My rate is 6.5%. I convert it to a decimal for 0.065. I divide by n, the number of times I'm compounding yearly. Now this is compounded monthly. There are 12 months in a year, so there are 12 periods that I'm going to compound. I'm going to use that same number in my exponent. T is time in years. They asked me to find this number after 3 years, so T is equal to 3. So I've set up, and now all I need to do is solve. A equals, so I would start again by figuring out your exponent. So 12 times 3 is 36. Then I take care of this stuff in parentheses. 0.065 divided by 12 comes out to a pretty ugly decimal. So when I add this all together, I get 1.005416 and so on. So this 6 actually repeats. 1.0054166666, etc. Again, keep several decimal points. I would say at least 6 decimal points out. Otherwise, you might get an answer that might be off by $1 and you'll be marked wrong. So let's keep simplifying. So A equals 12,500 times, we simplify the exponent and we get 1.21466716. Keep going. A equals 15,183.39. So that's the A in my compound interest. So I'm going to subtract that from what I originally started with. And I originally started with $12,500. So by taking the difference, I figure out how much money I gained in interest. 15,183.39 minus 12,500 comes out to 2,683.39. Remember, I'm rounding to the nearest, I'm rounding to the nearest dollar, so I take 2,683 as my final answer. So 2,683 is the amount of compound interest after 3 years.